we already discussed the previous experiment that was RC circuit as a differentiator, integrator, or high pass filter, low pass filter.
Yes, sir.
But yes, any doubt in the previous experiment? Any doubt RC circuit? Then you ask me. Otherwise, you start the next experiment. The third experiment. Okay, no doubt the previous experiment.
Sir,
Yes.
sir, in the last experiment, the graph paper which you told, that semi-log paper,
Yes, similar paper.
is not available here, so you can get the PDF from here, sir, that paper for printing that.
Hello. Your voice is not clear. Hello. Okay. Just to download from Google site.
Excuse me, sir.
Yes.
Sir, the semi-log paper, do we have to download the double y-axis, single y-axis? There are so many kinds of.
How many cycles means?
So there are so many kinds
There
of
are different
log
types
paper
of
available.
semi-log.
Okay. That is many different types of similar. Okay. Today I will upload the similar paper. Okay. Then you just download it. That similar paper from Google Plus.
Okay, sir.
Any other doubt? और कुछ है नहीं तो स्टार्ट करेंगे थर्ड एक्सपेरिमेंट. Okay, see, third experiment. V a characteristic of diodes. Okay, that is V means voltage, I means current. And here, what is the introduction? The objective of this experiment to study V a characteristic of different types of diodes. PN junction diode. To 30. Then here one ammeter and another is voltmeter. Ammeter is connected in series, but voltmeter is connected in parallel. This is the diode, cathode and anode. Cathode, anode, and this is one kilo ohm resistor. This is PN junction diode forward bias with LED. Similarly, same. First, you design the PN junction diode. Then after completed PN junction diode, just you remove the PN junction diode and fix a LED. When you fix LED in the circuit, first you identify the terminal, positive and terminal is positive and which terminal is negative. First you identify that. And after that you connect to design circuit. And third one is your Zener diode. In the Zener case, you design both forward bias and reverse bias. Both forward bias and reverse bias. After completing your LED, just you remove the LED You remove the LED and it is Zener. And last is the reverse bias. Now you go to the function of PN mentioned that observation table. The observation table, this is supply voltage. When you give the supply voltage 0 voltage, 0 volt, what is your diode voltage and what is diode current? Again, you increase the supply voltage, you give the 0.1 volt, and what is your diode voltage, what is diode current? Similarly, 0.2, 0.4, 0.6, and last volt is 5 volt. When you give the 5 volt to the PN junction diode, then what is your diode voltage and what is your diode current? LED. And this is the circuit diagram of 1 kilo ohm resistor and current meter. In this circuit diagram,
So the maximum current can flow through the ammeter in that way in
yes,
series
yes,
connection.
maximum current flow to the ammeter. But why you connect in series, not parallel?
It would means it would be damaged if we connect it in series in parallel, because then means due to the heating effect more current will flow and it
Yeah,
will.
any other reason?
Sir, to measure the current,
Voltmeter always connect in parallel. Okay, now you see here, this is variable power supply. This is positive terminal and this side is negative terminal. The positive terminal of the power supply connect the ammeter connected with the positive terminal of the diode or anode of the diode. The negative terminal of the diode or cathode of the diode connected with the 1 kilo ohm resistor, then another terminal of the 1 kilo ohm resistor connected with the negative of the power supply, first. And here is voltmeter, voltmeter connected in parallel. The positive terminal of the voltmeter connected with the positive side of the diode and the negative terminal of the voltmeter connected with the negative side of the diode. Positive to positive and negative to negative connected. If you connect it reversely, then not getting any voltage. Now what will you do? Just you vary the power supply. First you give the 0 volt. Then what is your current and what is your voltage? When you give the 0 voltage, current is 0, voltage is 0. Then just you increase the voltage. You give the 0.1 voltage. What is your voltage current and what is your voltage? Again 0.2 like that. And after that you calculate the DC resistances and AC resistances. DC and AC, that is static resistances and dynamic resistances. What is the formula for DC resistances? How you calculate the DC resistance? how we find out the DC resistance?
DC is that del V by del I, and AC resistance is to 26 millivolts by I.
Oh no no no. DC resistance is that is V by I, and AC for AC resistance del V by del I.
Del I, yes, yes, yes.
Yeah,
Sorry,
okay.
I
AC,
confused.
when you calculate the AC resistance or a dynamic resistance, okay, first you take one breadboard. And two multimeters. Then what will you do? Now the positive terminal of the power supply, this is positive terminal of the power source connected with the positive of the ammeter. No? Positive of the ammeter, voltage ammeter. And the negative of the ammeter connected with the positive of the diode. Here. Then the negative of the power source. This is very easy experiment. Experiment is very easy to design the circuit. Then a voltmeter connected with parallelly, negative to negative, direct connected, negative to negative, and First you give the zero voltage. When you give the zero voltage, what is your diode voltage? And diode voltage is zero, diode current is zero. Then you give the 0.1 voltage. Voltage is 0.1 zero. Suppose I give the 1 volt, you increase the voltage, then note down the diode voltage and the diode current. Suppose I give the 5 volt, okay, I give the 5 volt, the diode voltage is 0.573 volt or 573 millivolt, and your current is 4.3 milliampere, 4.43 milliampere. That means this is a silicon diode. This is a silicon diode. The silicon diode voltage is maximum 0.7 volt. This is a silicon diode. Then you fill up the observation table. Just you vary the power supply 0.1, 0.2, 0.2 up to 5 volt. Then note down the diode voltage and diode current. And then after that you calculate DC resistances and AC resistances. Okay. Then you plot the graph, simple graph paper. Then how you plot the graph? You take the simple normal graph paper, and this axis you take voltage, this axis you take voltage, and this axis, this is current in milliampere. This is graph for PN junction diode. PN junction diode. Similarly, for LED, same. And for Zener case, both you plot the graph both forward bias and reverse bias. Then your graph is like this: forward bias, and this is reverse bias. Then you find breakdown voltage. In the Zener you calculate and find out the breakdown. Zener observation table. Here, plot the forward VI characteristic, dynamic resistances and static resistances. Determine the cutting voltage. Here, plot the forward VI characteristic of a blue, yellow, and red LED. VI reverse VI characteristic determine the breakdown voltage. Okay. Here you take three LED, blue, yellow, and red. Then how you name that LED is red or yellow or blue? Now go to the direct here. Now just I remove the PN junction diode. Okay, LED. Here is LED. The LED now you see this side is anode and this left side is cathode and the right side is anode. Anode means positive and cathode means negative. Now start simulation. When you give the cycle there is no current. Sorry. Cathode there is a negative and anode is positive. But I connect to obviously. Okay. And anode is connected here. So now LED is blue. This is the red LED. Then how you take click on the LED and red, and you choose yellow, green, or orange, blue. You select any LED. Now blue. Suppose blue. Now blue LED. Similarly orange. LED, LED, here is the supply voltage, and here you just draw another two column, diode voltage and diode current. Then how you draw? This is suppose voltage. First one is the supply voltage. Okay, this is the diode voltage. In the diode voltage, R means red, G means green, and B means blue. Okay, this is and another column is that is milliampere diode current. Similarly, same thing R G B, red and green. B. You just fill up all the observation table. Then after that, you plot the graph. Then you calculate, you calculate the DC resistances and the AC resistances, and in the Zener diode you find out the breakdown voltage. Breakdown voltage in graph paper. Okay. Now you start. Now you start the experiment. The other cases, just you remove the LED, you fix the Zener forward bias, and again you just connect it.
For that RGB, we have to plot it in same graph.
Yes, yes.
RGB.
Red, green, and blue. All of you just fill up the observation. You design fill up the observation table. Now you tell what is your breakdown voltage in the Zener case. What is your breakdown voltage? Okay. So all of you design the circuit.
Sir, what are we using to provide that input current? The name of this, sir, can you please repeat? Input supply voltage. What is the source of that input supply voltage?
Power supply.
That is the power supply. Power supply.
Okay,
Power
sir, if
supply.
I type here, actually it is not showing in my Tinkercad. So what should I type to get this?
No. Power supply. Just you go to the search option. Okay, and just you write
Yes, sir.
POWER. Okay. Now power supply is here.
Okay, sir. Okay.
No. Okay. Here. What? Power supply. You write the power supply.
Yes, sir, it is showing,
Sir,
sir.
give me space after.
Yes. Here. This one. Already it's in power supply.
Okay, sir. Thank you. I got it.
Okay, now you all of you design the circuit. Any doubt, then you ask me.